Life Discovery Channel. Hello everyone, welcome back to this channel. Now let's review and discover the interesting thing.
In the beginning, there was the Big Bang, and it was an explosion, a real biggie. And like any explosion, it burst in all directions. Only in its case, giving birth to all galaxies and stars in them. Except, the universe we see is relatively flat. It seems like something doesn't quite add up here. We're used to thinking that the universe was born in the Big Bang. But we also forget that it's just a theory. And just like any other theory about the beginning of everything, the Big Bang theory has its flaws. For example, we're pretty sure that there is 5 times more dark matter in the universe than any visible or tangible matter. But we still haven't found any of it. And without dark matter, science can't explain how the matter that formed after the Big Bang could organize itself into galaxy clusters with vast empty voids between them. Another huge problem with the Big Bang is that we have absolutely no idea why it happened in the first place and what possibly could have caused it. Was there another universe that was constricting into a dot before exploding once again? Was there a parent universe that simply made a parallel reality of itself? Or was it a mysterious quantum force fields interacting with each other in some extreme and explosive way? We don't know, and probably have no way of figuring that out. And while I wouldn't personally try to call out scientists for these problems, because they simply show how little we know, there are still other problems that can't be ignored. Like the fact that the Big Bang didn't explode in a normal fashion, and instead produced the universe that is, as far as we know, flat. Even if it has the slightest curvature, that's not a sphere-shaped universe you would have expected from the Big Bang. Scientists largely agree that the universe is flat, and everyone learns evidence to that in school. We all know that if you draw a triangle, the sum of its angles will always be 180 degrees. And if you draw 2 parallel lines, they won't ever come together or break apart. They will always be parallel no matter how far they go. These 2 facts are true, unless you're drawing triangles and lines on a sphere instead of a flat surface. For example, if you try to draw 2 parallel lines on a globe as meridians naturally should be, they will eventually cross each other. The same goes for triangles. The sum of their angles won't be equal to 180 degrees. So, if the universe came from an explosion, it should somewhat resemble a sphere, right? Instead, no matter what size triangles you may draw between different points in the universe, their angles will still give 180 degrees when summed up. And photons of light that go parallel in a straight line will stay parallel on the whole journey. Almost. Here's another quirk related to photons. To be completely fair, they wouldn't go in a line in the first place if the universe were curved. Photons are known to change their path being pulled by a gravitational force of nearby objects. This effect is called gravitational lensing. Everything that has mass produces it, even you do, but on such a minuscule level that it almost won't even matter in observation. And then compare your body to something as huge as a planet, then a star, a galaxy. And how about a whole galaxy cluster? Now you get the picture. Speaking of pictures, the gravitational lensing is most obvious in photos of distant galaxies. For their light to come to us, it has to go through several clusters of other galaxies between us and them. The resulting photos are distorted. Galaxies in them always have weird shapes, as if someone messed around with a photo in an image editor. In reality, these distant galaxies look like every other galaxy in the universe, but the image is distorted because their light was curved by the gravitational lensing. But as sloppy and distorted as these photos are, they still prove that the universe is flat, because in the curved universe, such photos would be almost incomprehensible at all. Well, case closed. The universe is flat. Roll the credits. Yeah. Well, it's never like that in the ever-changing world of science. There is always some new evidence or research that ruins every theory built before it. This new curveball released in 2019 in Nature Astronomy Scientific Journal says that the light coming from the beginning of the universe is too curved to consider the universe flat after all. This ancient imprint of the youth of the universe is not the light you're used to. It's something called cosmic microwave background, or CMB. It's a faint trail of the electromagnetic radiation seen everywhere in the universe as a background noise, most clearly detectable in a microwave radio spectrum. This radiation is also called relic radiation because it almost literally comes from the past, dating back as far as 380,000 years after the Big Bang itself. In 2018, data was collected from the Planck satellite, built specifically to observe the CMB. This data showed the abnormal lensing of the faint light. For a year, this curve of light was just considered an unresolved mystery. But then came the theory that could explain it. The only problem is that it also considers the universe to be an inflating orb rather than a flat disk. This hypothetical shape of the universe was named the closed universe. The closed universe model can explain the distortion in the Planck satellite's newly obtained data, but it's still inconsistent with lots of other evidence that tells us the universe is flat. An alternative opinion on this data is that it's just a glitch in otherwise stable work of the satellite itself. For the moment, there's much more proof to the flat universe model being true than to the closed universe. But until the inconsistency in Planck's satellite's data is thoroughly inspected, we are left to wonder if everything we knew about the universe is not that reliable anymore. Well, to figure out the shape of the whole universe is the ultimate task, and it's okay if science stumbles on something unexpected and
This is so
mind-boggling
interesting.
every once in a while. At least there are a lot of relatively smaller things we're already pretty sure about, like no one will challenge the fact that our galaxy is a flat spiral. That's a funny one. In the same 2019, 2 different studies were published that proved our galaxy is not flat, but warped and twisted. Both of these studies are a part of the most ambitious mapping project ever. It uses data from 6 different survey systems catalogs. During their collective work, astronomers found that some stars are not in the place they should be if the Milky Way galaxy is supposed to be flat. It's not that unusual for spiral galaxies to be a bit twisted around the edges, but astronomers rarely voice the possibility that the Milky Way is one of them. Given that it's pretty hard to guess the shape of something that is more than 100,000 light-years big and contains at least 400 billion stars in it, no wonder our galaxy still surprises us. The study used information about positions of very special stars, called Cephids. These stars are from 100 to 10,000 times brighter than our Sun, and they pulse regularly and often enough to be extremely useful in continuous research. During observation of Cephids, it became evident that the outer parts of the Milky Way spiral can't quite keep pace with the galaxy's rotation, but they're still being dragged by inner part of the spiral. This leads to
See
the
you next
change in their
video.
shape and gradual formation of these twists around the edge of the galaxy. Well, my mind is now properly boggled. All I can say is that I like Milky Ways, especially when
For more useful information, click subscribe this channel to update new videos. Thank you.